Lesson 3.2, solving quadratic inequalities algebraically. Before we get started on solving algebraically, I need to make sure that you really do understand how to interpret an inequality. So let's take a look at that notes page. So on this one, it just goes back over the inequality symbols, what they mean, and then it gives us an example. So on this one, you need to remember that if it has a less than, you put an open circle, and I put mine actually on the number line. I don't do a hover. And this says that we're going to do everything less than, which is shading in the direction that this inequality sign is. So we're going to go in this direction and highlight the arrow. And if that's hard to see, I'll show you with my highlighter. There you go. Okay, the next one is a solid circle because it has less than or equal to. So we do a solid circle. And again, we're shading less than, which is to the left. And you also need to highlight that arrow. This is greater than, so we do an open circle at -2, and greater than is shading to the right, following the direction of the inequality. That inequality is actually going to look like the end of the arrow. That's kind of a little trick to remember that. Here, I've got greater than or equal to 6, so I do a closed circle, and again, I'm shading in the direction of this arrow. They look the same as the symbol, and I highlight the number line. Now, some teachers I've seen do this and they hover it above, and I really want mine on the number line. Make sure that open circles and closed circles are very clear. All right, compound. This one tells us where to start, and on this particular problem, they may give you less thans, or they may give you less thans or equal to, so you have to pay attention. This is just one example. So we're doing a closed circle, and it goes all the way to 1. And an and is connected together. In class, you'll see me do my thumbs together for an and on the next one for ors, we're going to go out. And I'll always, you didn't see that very well. So we do ands together and ors are out, and you'll always talk about row, row, row your boat, because the oars on a boat go out. So on this one here, open circle for this particular problem, and an open circle at 4. And rows on a boat go out. So this goes to the edges. Outward. So in class, you're going to hear me talk about row, row, row your boat. Your oars go out for your compound. Ands go together. The golden rule is anytime you multiply or divide by negative, make sure you flip the inequality sign. And I always put my variable on the left. If you have to move the variable to the left, it will also cause the sign to flip. It means the same thing. So on the back, there's some that we're going to practice in class to see how you do to make sure that you understand these. You can try them before you get to class, or you can wait in class to do these. Now we're going to go back to the notes. Here are the steps for solving a quadratic inequality. If you've downloaded the notes page, it'll already have it on there. We'll talk about this as we work the problems. We're going to use the factor and solve method, so all of our problems are going to factor. Now that may not be the case that they are not factorable, but we haven't learned any of the other methods yet, so all of these are going to factor and solve. Be mindful of open circles and closed circles. We're going to talk about what does it mean to test the 3 values, and that 7th step is so critical. Some students forget this one. It's the whole purpose that we just reviewed, reading and interpret a graph. So on your worksheet, let's take a look at problem 1. So we need to change the inequality to an equal sign and then factor this. Now I solve each of these factors, and I get these 2 numbers. Now I have to go back and look at the original inequality and go, okay, is that an open circle or a closed circle? Now I have to test something in each of the 3 zones. I have a left zone, a middle zone, and a right. You've got to pick any number in those zones. You are not allowed to choose the numbers that we have plotted on the number line. So I've chosen this one. If I plug in a -7 back into the original inequality, does this make a true or false statement? All right, it makes a true statement. And when we're doing inequalities, you always shade true sections. So we're going to shade that section. All right, let's pick something in the middle. My favorite, no matter where this number is, provided it's not one of the ones that you plot as a circle, is always pick 0. It goes really fast when you plug it back into the original. So is this a true or false statement? It's a false statement, and we will not shade false statements. All right, I've chosen another number here. You could have chosen any of the numbers greater than 3. True or false? And that's true, so we're going to shade the last one. Now here comes that last step. You've got to interpret this graph. And think, row, row, row your boat, oars go out. So I'm going to write that it's all the numbers that are less than -4 or all the numbers greater than 3. Watch your signs. Watch your signs. They're going to match up with the ends of these arrows. All right, next problem. So we're going to change the inequality to an equal sign. And on this problem, we need to move everything over to one side so that your squared term stays positive. Now you're ready to factor this. Solve each of your factors, and now it's time to plot them on the number line. So we have to go back and look at the inequality. Closed circle or open circle? Now we need to test points in each of the 3 zones. There's a left, middle, and right. You're not allowed to test the points that you plotted. So I've already picked out some for us. My favorite, 0. We go back and plug it into the original inequality and see, is left side, is that -16 greater than or equal to 0? True or false? And that's false. -16 is not greater than 0. We will not shade that region. Now pick any number in between. I've chosen 5. Plug it back into the original inequality. And is the left side true? -16 greater than or equal to, is that true or false? And that's true, so we're going to shade that. And now we need to pick another one. Now on my number line, I don't have anything past an 8, but we do know that that keeps going on forever. So you could choose any number, like even 1,000 if you wanted to. I did not choose 1,000, I chose 10. And that's a false statement, so we won't show that. So we're now ready for that last step. Interpret what you shaded. And see, these are connected together, so this is a compound. So the 2 goes first. Go back and look. We're going to always use the less than symbol, but on this problem, it'll be less than or equal to. So 2, less than or equal to x, less than or equal to 8. It always goes in the order. See, 2 is on the left. Always use the less than, x, less than, and then 8 goes last. Problem number 3. So we're going to change this to an equal sign and get everything to one side so your squared term is positive. All right, when factoring this one, we should always keep our eyes peeled for a GCF. And I see that this one does have a GCF, so we're going to factor that out. Now put each factor equal to 0 and solve. Now it's time for you to start thinking, what kind of circle? Open circle or closed circle? So you have to go back and look at the inequality. This is telling me open circle. Now at this time, these are really squished together. When we get ready to test our 3 zones, anything from the left, when I have to choose a middle point, you're going to have to pick a decimal on this one. Something easy to choose would be like -6.5. That's in the middle. My favorite one, here's 0, hanging out over here on the right side. So go ahead and pick any numbers that you want to. Check those. You might want to pause the video because I'm going to go ahead and show the answer. Now interpret the graph. See, oars are going out. So it's all the numbers that are less than -7 or all the numbers that are greater than -6. And I put them always in order. The number on the left I write first, the number on the right I write second, so that my inequalities always match the end of my arrows. Okay, this one has a problem when we get ready to put it equal to 0 and solve. You've got a negative squared term. Your quadratics need to have a positive squared term. So we're going to have to factor out a negative sign on this one. Now we can factor x squared minus 2x minus 3. The other way to fix that is just to have moved everything over to the left side. All right, open circle or closed circle? Good, closed. Test your points. This one I don't have any already picked on the PowerPoint. And then interpret the graph. Oars go out. The number on the left I write first so that my arrows match my inequality. The number on the right goes second and my arrows match my inequality. I have an or equal to because the original problem also had the or equal to. All right, factor and solve. I'm going to try to make this under a minute. This one you do need to convert to a decimal so you know where you need to put the number. -2.5 is halfway in between -2 and 3. Closed circles because it's an or equal to. Test 3 points. There's my favorite one, 0. Interpret your graph. Ors go out. The number on the left I write first so that my arrow matches my inequality. The number on the right goes second so that it matches my arrow in the inequality. All right, this one I've got a squared term that's negative, so we're going to need to move everything to the other side. So how do you move a negative 2x? You add it. How do you move a positive 12x? You subtract it. That's where those numbers came from. This has a GCF, and then you need to factor and solve. We're going to graph with a closed circle. Then you're going to test 3 points in between, any 3 that you want to. If it's a true, you shade. If it's false, we don't shade. The last step is interpreting the graph. This one, ors go out. So I'm going to write the number on the left first. My inequality is going to match my arrow. And the number on the right goes second, where my inequality matches my arrow. This one does have an or equal to, so make sure you put the bar underneath. All right, for problem number 7, we're going to go ahead and set this equal to 0 and factor and solve it. Okay, so on this one you've got a 1/3, so you can convert it to a decimal or just realize that it's really close to positive, almost there at positive 1. Negative 1. You need to ask yourself, open circle or closed circle? Pick 3 values, one on the left, one in the middle, and one on the right. If it's true, we're going to shade, and if it's false, we do not shade it. Then you have to interpret your graph. Ors go out on this one, so the number on the left I write down first so that it matches the arrow. The number on the right, which is 1/3, goes second, and the inequality will match the arrow. This has an or equal to, so sorry about that. Has an or equal to, so make sure you put the bar underneath. Open circle or closed circle. Test your 3 points and shade true sections. Oh, this one's different. I don't have ors going out, so this was an and. The way that you write your and statement is the number on the left goes first. You always use a less than or equal to x, less than or equal to, and then you always put this number on the right last. See? Always use less than or equal to x, less than or equal to. All right, this notes was a little bit long. Sorry that we went over 10 minutes. See you in class.